welcome to everyone. In this edition of BIS Talks, we will discuss about the Ready Mixed Concrete or RMC certification scheme of the Bureau of Indian Standards. Concrete is one of the most versatile materials used in construction activity today. It is the highest used man-made material on per capita basis because of its cost effectiveness, durability and localized availability. It is used in floor and roof slabs of masonry building and in the entire framing elements of the concrete framed buildings. It is also used in other structures such as concrete roads and pavements, bridges, flyovers, water tanks, dams, hydraulic structures and number of other special structures like bins, silos, chimneys, etc. The quality and durability of buildings and other structures substantially depends upon the quality of concrete produced and on its placement, compaction and curing. Let us hear more about this from an officer of civil engineering.
The quality of concrete produced depends upon the quality of its ingredients, namely cement, fine aggregates, coarse aggregates and water. Depending on the requirement and properties to be achieved, additional ingredients like mineral admixtures such as fly ash or slag, chemical admixtures like superplasticizer, and at times minor constituents like silica fume, ultrafine slag and metakaolin may be added for imparting special properties. Apart from these materials, the quality depends upon proportioning them and care taken in their mixing, transportation and placing of fresh concrete at the site of use in the structures.
Ready-mixed concrete or RMC produced at plants offers this facility of adherence to strict regime of controlled production as per the laid down norms. By definition, ready-mixed concrete is the concrete that is mixed in a stationary mixer in a central batching and mixing plant or in a truck mixer and supplied in fresh condition to the purchaser either at the site or into the purchaser's vehicle. Additionally, RMC relieves the consumers of tasks such as procurement of materials, their storage and production with adequate quality control, which are taken care of by RMC supplier. This way, ready-mixed concrete is not only a material but also a service. Bureau of Indian Standards has formulated a detailed Indian standard for RMC, IS 4926 Code of Practice for Ready-Mixed Concrete. The standard details all aspects of required quality controls to be exercised for use of right quality of raw materials during production, transportation and delivery of concrete. It is very convenient these days to get ready-mixed concrete. You just have to make a call to the RMC plant, give the specifications of your requirement and the RMC will reach your destination. However, to be doubly sure that the RMC is being prepared with the set norms, one prefers to go to the companies which operate under a dependable third-party certification scheme. This will ensure not only a well-structured system, but it will build confidence in the users of RMC.
This ready-made solution, conceived and implemented by the BIS, not only addresses the problems of the builders and contractors, but also proves to be a one-stop solution for all construction activity. In India, RMC was initially used in 1950 in the form of concrete produced through centralized batching plant during the construction of dams like Bakranangal and Koina Dam. Commercial RMC in India started in 1990s and currently all major cities of the country have availability of commercial RMC plants to serve building as well as infrastructure construction. With rapid development today, there is increasing need for better infrastructure, thereby fueling the demand for RMC for construction. Today, RMC is required generally in major concrete projects like dams, roads, bridges, tunnels, canals, etc. in all kinds of residential and commercial building construction from individual home builder to high-rises, for concreting in congested areas where storage of raw materials is not possible, construction sites where the intensity of traffic acts as an impediment for production of concrete, when supervising staff and laborers are limited, and where there is a need for reducing the time of construction. BIS is operating a quality management system certification scheme as per ISO 9001 successfully for the last few decades. It is now also operating the RMC certification scheme, which ensures all the benefits of quality management system along with compliance to technical provisions of RMC enshrined in IS 4926, thus ensuring quality concrete to consumers in a sustained manner.
To explain this highly technical subject in detail, we will see brief video of concrete production in an RMC plant, its transportation and delivery to the construction site. Aggregate is first stored size-wise. Cement of various types is stored in bags or silos. Potable water is stored. Mineral admixtures and chemical admixtures are also required. The raw materials are weighed and loaded. Adequate water is added. Proper mixing is done to obtain homogeneous concrete. Mixed concrete is loaded in the transit mixing trucks. Vehicle leaves for the destination with delivery ticket. Certified concrete is thus delivered at the doorstep. We will now understand step by step how quality control is exercised at RMC plants under BIS certification.
First and foremost is the quality control of the materials used for RMC production, which are cement, fine aggregate, coarse aggregate, mineral admixture like fly ash, slag, etc., chemical admixture and water. Cement of different types and grades have to conform to the concerned Indian standards. Cement such as OPC, PPC and PSC are commonly used for RMC. Coarse and fine aggregates have to conform to IS 383 and stipulations of the Concrete Code IS 456. Aggregates are tested mainly as per IS 2386 and weekly and monthly test records maintained and periodically verified. Water used is tested for conformity as per IS 456. Water may be from the municipal supply mains or non-mains like borewell. Samples of water from these sources are tested periodically for requirements such as maximum chlorides, sulfates and suspended matter. The tests are conducted periodically and records maintained. Admixtures used such as fly ash and slag are tested for conformity as per relevant Indian standards and their records maintained. Chemical admixtures may be used as per IS 456 to alter one or more properties of concrete, particularly to reduce the water requirement. This helps in making workable and durable concrete. The chemical admixtures are tested for compliance to IS 9103 and test records maintained.
Before the RMC plant commences production of ready-mix concrete, while observing quality controls under the BIS RMC certification scheme, the plant requires certain information about the concrete that the consumer wishes to procure. These include concrete grade for the desired compressive strength, minimum cement content, any use of mineral admixture, maximum water-cement ratio, nominal maximum size of aggregate, cement type and grade, workability of concrete as slump methods of placing, curing, etc. It is recommended that prior to supply taking place, a meeting is held between the purchaser and the producer. Generally, grade, workability, method of placing, curing, exposure condition and additional information like minimum cement content etc. are provided by purchaser as per project specifications. Now, let us hear from an expert in the RMC plant.
Many times customers are asking their different requirements, which we are conducting trials, making concrete in small mixer, taking all samples as per their required properties, conducting tests, and after getting good results, we are taking in production and supplying to the customer. Such type of mix, when reaching at the site, we are confirming the properties required by the customer at the site also, taking some samples, and also if required we are taking Q samples and specimens are bringing back to the plant, keeping proper curing and testing in the presence of customers.
We are taking the grade of the concrete from M10 to M15 with a higher grade of concrete, and especially they are supplied the SCC, the self-flowing concrete. That concrete we are using in a very dense reinforcement, that is very useful for us. The self-compacting concrete is the self-vibrating concrete, and after de-shuttering we are seeing that there is a no honeycombing. That prove this concrete quality is very good. The strength wise that is a very good. Supply wise they are the very good.
The BIS certified RMC plants are required to exercise diligence and proper controls in all aspects of concrete production, such as plant and equipment involving material storage and handling, batching plant and equipment, measurement of materials and mixing, plant safety and maintenance, environmental considerations, and delivery ticket.
IS 4926 has specified certain requirements for all plant and equipment required in the RMC plant. Material storage and equipment requires special attention to help retain the desired quality of respective material. The RMC plant is required to store different cement types and grades in separate bins or silos, duly weatherproofed, or in bags in stores duly protected. Fly ash and other mineral admixture is stored in separate silos. Aggregates are stockpiled with adequate protection from contamination. The batching plants and batching equipment are required to meet certain prescriptions for ensuring accuracy and effectiveness in concrete production. Hoppers for weighing materials are equipped with controlled loading and efficient discharging mechanisms. Dust seal is provided on hoppers between the loading mechanism and weigh hopper to prevent emission of dust. Separate dispensers are provided for each type of chemical admixture being used. Fly ash slag, when batched through cement weigh system, the weighing device and system is completely emptied to avoid their mixing with cement. Cement, aggregates and mineral admixtures are measured by mass. Water is measured by volume or by mass. Necessary allowance is made for free moisture content in aggregates. In case of fully automatic production systems, the same is fitted with control equipment for monitoring the correct operation of weighing and batching. Accuracy is ensured for proper quality assurance of RMC within strict tolerances. For cement and mineral admixtures plus minus 2%, aggregate chemical admixture and water plus minus 3%, all weighing and measuring equipment are tested and calibrated over their full working range. Mechanical or knife edge are calibrated at least once every 2 months. Electrical or load cell systems are calibrated at least every 3 months. Continuous weighing systems are checked using preset quantities with those actually produced. Calibration of weighing equipment is done by competent and trained personnel. Now, let's hear from the BIS official on the methodology used for mixing.
The two types of mixers are stationary or central mixer and truck mixer. These mixers shall not be loaded beyond the rated capacity. Every time before adding the concrete making materials, any remnant concrete or water should be removed. To ensure uniform mix of concrete, adequate mixing time is required after adding all the materials including water. At the end of day's work, both these mixers are cleaned free from set concrete. Periodic inspection and maintenance of these mixers and replacement of mixing blades is done to produce consistent and quality concrete. Similarly, the RMC plant has a variety of moving machines, concrete making materials including cement and high working heights which require periodic cleaning and relevant safety measures as per IS 4926 round the clock. The BIS certification scheme also provides a detailed list of maintenance checks to be carried out as per the schedule in a timely manner.
With pollution and vibration eliminated from the construction site, the RMC plant, where the actual mixing is done, also needs to adhere to the BIS guidelines with respect to overall plant safety, reduced or nil air pollution, minimum noise and vibration, etc. Even the effluent water or wastewater needs to be suitably managed. The scheme addresses this aspect, including spillage of fuel, oil and chemicals. A record of all these environmental conditions is examined periodically by the BIS team as part of sustainable concrete production. The RMC truck driver is provided by the plant operator with a delivery ticket containing relevant information and details of the concrete produced using special codes, decipherable discreetly, and the addressee. The purchaser of concrete can verify, including the details of the truck printed on the ticket, which serves as a token of assurance. The most important aspect is to ensure final quality of the concrete, which in turn requires controls at every step of production of concrete. These include forward control, immediate control, and retrospective control measures specifically to be carried out before, during, and after the production of concrete. These controls and corresponding checks are carried out as part of the BIS RMC certification scheme.
The forward control involves using a system of controls and corrective actions through visual checks, sampling, and testing of quality of purchased materials. Raw material sources are visited regularly, and materials like cement, fly ash, GGBS, aggregates, sand, water, and admixtures are used from only approved sources after thorough testing, or should have BIS standard mark, that is ISI mark, on them. Incoming raw materials are tested as per defined frequency in the quality control plan. Storage of materials is done in such a way to prevent contamination. Aggregates are stored in separate bins over a hard base as segregated stockpiles to avoid intermixing and contamination. Cementitious materials and admixtures are stored in separate silos or tanks. Mixed design for concrete of various grades is performed by qualified concrete technologists, and laboratory trials are performed to validate the designs, and records of the design mixes are properly maintained. In order to ensure that the quality of concrete is maintained during transit period from plant to site, prior testing is performed for workability retention time of 2 to 3 hours. Allowable time for using the concrete based on the mixed design is declared by RMC supplier on the delivery ticket. Project requirements specifying specialized criteria for concrete like peak core temperature, design life, chemical resistance, aesthetics, etc. are analyzed by a team of competent concrete technologists at RMC plant, and specialized concrete mixes are designed to meet such specifications in collaboration with project teams if required. Regular plant maintenance inspections are performed as per documented procedures. RMC plant typically employs pan mixer or twin shaft mixer for superior mixing and hence uniformity of concrete. The mixers are periodically checked for wear and tear of arms and mixing plates to ensure mixing efficiency. Transfer and weighing equipment are regularly calibrated to ensure accurate batching of individual ingredients. Plant mixers and truck mixers are kept operational and well maintained.
The immediate control involves instant action that are taken for production and product control to monitor the quality of concrete being produced. Included materials are batched using high precision electronic load cells, and the mass is recorded for every load using computerized systems. Workability is controlled on continuous basis by performing proper moisture correction to account for the wet or dry aggregates. This ensures that water-cement ratio of the concrete is accurately controlled and the desired hardened properties of concrete are achieved. The slump test is performed at plant before dispatch in desired frequency to ensure proper workability of concrete at site. Visual checks are also performed by trained technicians to ensure that concrete is cohesive without segregation and bleeding. If requested by the customer, workability tests are also performed at site in desired frequency to assure compliance within tolerance limits. During transportation of concrete, the concrete is kept agitated by rotating the transit mixture at a low speed of 1 to 3 rpm to prevent fall set of concrete. On arrival at the site, the drum is rotated at mixing speed of about 8 to 12 rpm to ensure the proper consistency of concrete at the time of discharge. It is advisable not to add any additional material in the transit mixture drum without proper authorization from the quality control engineer of the RMC plant. In case, due to harsh weather and traffic conditions, the workability of concrete is found lower than that specified, small amount of admixture is dosed under the supervision of competent technicians to provide suitable workability at the placing point. In extreme hot weather conditions, it may also be advised to cool the concrete and/or wrap the transit mixture drum with wet Hessian cloth to prevent sharp drop in workability during transit. At site, RMC is often lifted and poured into formwork of structures at various heights using mechanical equipment called concrete pump. The use of concrete pumps ensure faster casting of structures with enhanced uniformity and lesser use of laborers.
The retrospective control involves testing of compressive strength of concrete cubes at 28 days and analysis of results to compare with the target values. Cube specimens are cast from supplied concrete as per frequency specified in IS 4926 for assuring the compliance of concrete strength. Sampling is done by trained technicians following proper procedures laid down in Annex C of IS 4926 and IS 1199 Part 1. After hardening, these cubes are demolded and placed in curing tanks under standard conditions for testing at 7 and 28 days as per prior agreement. Concrete purchasers are encouraged to witness the testing process at the RMC plant laboratory for assurance of transparency. The cube test results are also analyzed statistically for normal distribution, standard deviation and average of strength. Based on the statistical analysis, areas of improvement in quality control process are identified and continual improvement is made. Proper stock control procedures enable verification of materials used in concrete. Complaints regarding faulty concrete are handled as per documented procedures and appropriate corrective actions are taken.
RMC plants have competent person to interpret the specified requirements and relate these to mixed design criteria, systematically review specifications and orders placed by the purchaser. He records this formally and hands over correct instructions to the plant operator for batching and mixing. In any case, all the information and requirements of the purchaser are clearly identified and recorded in the quotation. The BIS scheme requires that all personnel involved in concrete production, delivery and the quality management have received training and are well versed with their duties.
A quality manual including authenticated copy of relevant and updated Indian standards are prepared by the plant in line with the RMC scheme of BIS. Further, work instruction, control charts, forms and formats are documented, maintained and updated by the producer, which in turn is inspected by the BIS team. The auditing team satisfies itself with conformity of the plant to environmental laws, factory license, ownership documents, location and layout of factory before reporting as part of the scheme. All documents and records are maintained for at least 1 year by the producer as part of the continuous quality program. Every time, the BIS audit team examines such records while also checking the in-process controls during working of the plant. A sample of the documents and records maintained are production and delivery having batching instructions, batching records, delivery tickets and equipment calibration and plant maintenance, materials and production control involving concrete production and materials purchase, usage and stocks and certificates or test results for materials, and finally production quality control, which has the control test results. Documents and records include quality manual, Indian standards with latest amendments, work instructions, control charts and forms.
Now, after the application, what is the process of the grant of license?
Now the concerned regional office processes the application for grant of license. This includes two audits. One audit is stage 1 audit and second audit is stage 2 audit. These audits are carried out to gain sufficient evidence related to conformity to the management system implemented by the organization. Now what is stage 1 audit? Basically the purpose of stage 1 audit is to assess the organization's department for the stage 2 audit. During stage 1 audit, following things are verified. Number 1, scope and boundary of the implemented management systems, type of services covered, processes involved and relevant statutory and regulatory requirements, whether they are complying it or not. Number 2, confirmation of the information submitted in the application and whatever retained and maintained documents as per the standard they are maintaining or not. Number 3, a review of the documented information of the implemented management system, for example, documented processes and procedures, policies, etc. If any non-conformity is observed in stage 1 visit, the same is communicated, and after satisfactory actions, then only BIS decides about stage 2 audit. Now what is stage 2 audit? The purpose of stage 2 audit is to evaluate implementation, including effectiveness of the management system to be certified. What are the activities to be undertaken during stage 2 audit? Information and evidence about conformity to all requirements of management systems under certification, then performance, monitoring, measuring, reporting and reviewing against performance objectives and targets, ability to meet statutory, regulatory and contractual requirement, operational control of the processes, audit of all departments as per schedule is carried out or not, relevant evidences are collected, verified during our audit also. The auditor also have to see whether their internal audit and management review are effective and have been done as per procedure and their whatever they have decided to do and our standard. Then our auditor will audit all of their departments as per the audit schedule and relevant evidences will be collected and verified. Now if any non-conformity is observed, the same is discussed with auditee and system coordinator and then communicated to the auditee for taking appropriate action with a time frame of 45 days as per our guidelines and terms. Once the audit activities are completed, DDG region takes decision to grant the license to the applicant. The license is granted for 3 years, during which there will be 2 surveillance audits conducted at an interval of 1 year. BIS follows a robust certification process utilizing competent and experienced auditors. Over the years, as the management system stabilizes, the organization can make use of this management system as a tool to improve their system.
There we are, ensuring clean construction sites, high quality durable and sustainable concrete produced under factory control, delivered at your doorstep. That's all for now.